So good afternoon, everyone. This is Samarth Agrawal, and as you know, that I will be covering up the PYQs over the topic limits, continuity, and differentiability. So without wasting some time or any time rather, let's start with the question. What is the first question say to us is we have a question as cos root of cos minus cube root of cos x divided by sine square x. So yeah, we'll just use the L hospital rule. Press L rel sorry, it's L hospital, right? It's hospital. So I'll just say hit simply eligible rather not create any nuisance. So let's just try to solve covering the solution first. So half cos x, right? And then to the power half minus half, and then cos x integration is differentiation is minus sin x, right? Then minus of 1 by 3 cos minus 2 by 3 minus sin x divided by 2 sin x cos x. So let's just cancel the sign here because it has to be cancelled. And now what are we left with? Half cos x to the power minus 1 by 2 minus 1 by 3 cos of minus 2 by 3 power 2 by 3 and 2 cos x. And then our x is going to 0. So taking the cos to 0, we have half cos of 0 is 1 to the power minus half. That does not make any sense. Then 1 by 3 cos x again is 1 to the power of minus 1 by 2 by 3 minus 2 by 3. And then 2 cos x. So cos x again would give me 1. So this simply becomes as 1 by 6 into 2. That is 1 by 12. This is my limit. Let us check the answer. It is right, but there's a negative sign also included here. So where did we miss our negative sign? So yes, there is a minus sign common here. We have to take a minus sign common. So there will be a minus sign as well. Because we are cancelling sin x with sin x, right? So negative sign of the sin x in the numerator has to pertain or has to remain. So it's a very easy application. We are starting slow. We'll warm up later on with some more tough questions. But for JEE-Mains, right? We're just targeting JEE-Mains for the time being. Let us see the next question. Okay, so next question, I'll just try to hide the solutions few steps because I don't really just want to go through the solution. We'll keep the answer for our convenience, but not the solution. So what do we have? We have to calculate limit x tends to 1 and we have an algebraic expression. So let us try solving this and convert this. I'll be a little bit faster here, so try understanding it with your own capacity. So x square minus 1 by x, or I could be slow for someone, but it really depends. Whole to the power minus 1, and then plus, plus 3 times of x to the power. Just give me a minute. I'll be. Yes, so getting back to the question, we were doing this, right? So if you see, there's a commonality between the factors here. So let us solve it a bit more. So x, this, and now taking this as this and this. Again, I'm saying this, but what I mean is taking x to the power minus 1 down in the denominator and making the expression look like something like this. And we can cancel this because at x is equals to 1, these will be equal. So we will cancel this out and we'll get a 3x here. And now again taking the denominator here as well and writing minus 4 here, write minus of this. You get it? What I did here? I took the LCM, then took a negative sign as well. Then I have a same and common factor, so minus, this becomes plus and this becomes minus. And let me just use a eraser here because I have to consider the power of minus 1. Really important to do that. And now, if you rewrite it, what I'm left with is minus x square minus x minus 1 upon 1 minus x cube to the power minus 1. And I can expand this and write as minus x square minus x minus 1. 1. Let me just use a eraser once again. And I'll be left with 1 minus x, 1 plus x square. And I'll cancel this out. And I'll be left with a x minus 1, right? This is whole to the power minus 1 again. So I'll cancel this. I'll remain with a negative sign. And this negative sign multiplied down would give me x minus 1. And taking the power minus 1 would give me x minus 1. So x minus 1 plus 3 times of x gives me 4x minus 1. And taking x is equals to 1 would give me 3. So I get my answer as 3. Where is the answer for 2? Yeah, we have our answer for 2, that is 3. Very easy, just simply solving questions and cutting out some factors. Since they were the factors that were causing problems in calculating the limit, because it's often a case where you have to cut out the factors that were going to infinity while calculating the limit. So we'll have to consider such cases. We obviously already did these types of questions in our theory as well. So let's try to avoid some of the easier questions and move towards a bit tough ones. But for the time being, for the initial part of the lecture, we'll continue with the questions that we are doing right now. Let us see. So, okay. So what are we doing is we have to solve this, right? So let's hide the question first. Okay, sorry, the solution first. And talking about this. So I have my limit x tends to pi by 3 2 sine of x minus pi by 3 upon 1 minus 2 cos x, right? And simply at x is equals to pi by 3, we can see that it is going to 0. It is a 0 by 0 form, so LH can be applied. So let us apply LH. So 2 cos of x minus pi by 3, and this gives me minus or plus of 2 sine x, okay? And this at pi by 3 won't cause me any trouble, right? So this would give me 2 times of cos 0, and this would give me 2 times of sine pi by 3. Sine pi by 3 is sine 60, and that is root 3 by 2. And cos 0 is 1, so 2 root 3 by 2, so 2 into gets cancel. I'm left with 2 by root 3. Very easy. Okay, so let us see the solution also once. I think they have went with the trigonometric approach or using some formula of the trigonometry. You can go that way also, but try applying the LH rule if possible. It's the easier way out and saves you a lot of time as well. So what are they doing here is, okay, yes, this is a valid formula that you can use. Okay, so we are done with this. Now going back to the next question, no, going to the next question. We have if f of x is equals to this, now we have to calculate this. Okay, so we know now this kinds of questions are done with 1 to the power infinity form. See, first thing that comes to one mind is to realize which form of limit. So yes, the first question that one should come across is that what kind of limit is it is. It is infinity by infinity or 0 by 0, or is it 1 to the power infinity or something like that, right? So we have to be very like sure about what the kind of limit here is. In this case, if you check, putting x is equals to infinity gives us a limit which tends to, I'm saying a limit which tends to a form of 1 to the power infinity, right? And you know how do we solve that? We solve that by making it in the terms of e to the power x. See how we do that, I'll tell you. So you know that, right? We can write y to the power x as, if we take log on both sides. So if we don't take log also, I am left with e times log of x, oh sorry, y, and this is x. So this is the same representation. So if we take the same representation and try to solve it, you get answers. And this can also be written as e to the power. Just give me a minute. Yes, this can also be written as x times of this expression. Like if you see the expression that they're written as, so it can be also be equalized as this, and we have a x here, and what are they doing? Mm, okay, yes. So this can be written as log. We can remove the x, and this can be written as y minus 1. So we solve this. I forgot my basics, guys. I'm really sorry. So see what we did. First, we wrote pi to the power x as equal to this, and then we can write log y, and we can write log y as, and we can write log y as y minus 1 when y tends to 1, right? So this is what our concept is, and you can see that exactly has been done here. If you write in, I'll just go to the solution. I'm not writing a solution for you guys because it's very, the explanation of the concept is that what really matters here. So we first, what we did was we recognized which form of limit was it. So it was 1 to the power infinity, and we know how do we solve that. We take the powers, the expression in terms of e to the power, like expression in the power of e. So we did that, and we get this kind of an expression, and this gets converted into this, and we solve this x into y minus 1 for this. Here in the case, y's are this fraction, so we did exactly that and calculated at x is tending to infinity. So we got a value of 4, and that the answer is e to the power 4. I hope you got it. I know sometimes it can be new if you've already not studied the types of limits that there are there. So it can get a bit murky and messy, but you'll have to just go through the practice of it and get an idea of it. So if A and B are chosen from 1, 2, 3, 4, 5, 6, 7, 8 randomly with replacement, guys, the probability that this equals to this. Okay. So let us see how does the property sorry for my stammering, guys. So let us see how does it look like. So first case, if we take if x tends to 0, right? And this is again our 1 to the power infinity form, right? So we are left with e to the power 2 by x into ax plus bx minus 2 by 2, where limit x tends to infinity. Or sorry, 0. 0. So this is what we are doing here. And now on calculating this again, if I check the limits, I'm let's cancel the 2 and 2 here, and I'm left with ax log a plus bx. I'm just applying L hospital rule or L hospital rule because it is very convenient to do so at this point. So this is what I'm left with, and putting x equals to 0, I'm left with log a plus log b, and that is log e to the power log of a plus log b, and this is log of ab, and this is gives me ab as my answer, right? And the probability of getting ab is equals to 7. So it can only be done with 1 comma 7 and 7 comma 1, and that is 2 by 49. We got the answer, right? The probability part is very easy. This logic 1 to the power infinity could be a bit tricky for you guys. So kindly check this format. This format is also really important to understand, the 1 to the power infinity form. So what we did was, let us go through the solution. We are first recognize what kind of infinity do we have here, or what kind of limit we have, not infinity, but what kind of limit do we have? Is it the 0 comma 0 form, 1 by 1 to the power infinity form, or infinity by infinity form? So you have to solve all these kinds of uh, limits, and they might have a different kind of way to solve for each of those. Because like for 0 to 0, or we use L'Hopital rule. For infinity by infinity, we try to convert by taking the reciprocal of 1 by x and divided by the highest power x. It was very similar to that. We'll not get into the details of the theory. We'll try to apply them in the questions. So let's do the next question. We have cot x minus cos x. Then again, we have pi minus 2x to the power 3. So again, you can apply the L'Hopital rule because it is again going to 0. So let us apply it. What is the differentiation of cot x? You guys tell me. It is minus. Is it minus or is it plus? It is minus of cosec. Yes, so it is minus of cosec square x. And then for cos x is minus of sin x, but there was always a minus, so we cancel it out. Then we have 3 times of pi power 2. Again, sorry, excuse me. So this could go on and on for like quite some time. So rather than going this way, we can calculate by putting the uh, x as pi by 2 plus h. Why we are doing this? Because it could really save us some time, and the algebra would be really easy, as the solution is also saying so. And also the lower part will be really easy to solve, and the upper part would really be converted into different forms of theta and different trigonometric forms, so it won't hamper our calculation there. So let us just go through the solution, what the solution is trying to say. First, we solve this by taking x is equals to pi by 2 plus h. Okay, we do that. And then we put it here, and this is what we get. And this is the final part. So this is very easy to solve. We can directly use L'Hopital rule again and again and get our values. So this is what we get. So I hope you got the solution right. And now talking about the different next question, we have given a function g of x, that is root of 6 minus 2x. And then we have h of x, that is equal to 2x square minus 3x plus a. Then we have to evaluate h of g of 2 if, okay, first things first, so let us do that. H of g of 2. So what does h of g of 2 looks like? So where's my pen? Yes. So it is 2 times of root of 6 minus 2x whole square minus 3 times of 6 minus 2x plus a. This is what my h of g of this looks like. I'm putting g of 2 here, so I'm left with this. This is root 2. So root 2's whole square minus 3 root 2 plus a. And this is root 2's whole square is 2. So 4 minus 3 root 2 plus a is my h of g of. Okay. And now calculating the f of x. So f of x says that it is equals to g of h when x is less than equal to 1, and it is equal to h of x when x is greater than 1. So we have to find a that f is continuous. For for f to be continuous, it should be f of 1 minus should be equals to f of 1, and should be equals to f of 1 plus. So let us see what does it look like. So f of 1 is equals to g of, sorry, f1 minus is equals to g of x, and this is equals to h of x. So let us solve. G of 1 is equals to root 4 that is equals to 2, that is equals to g of 1, and h of 1 looks like 2 minus 3 plus a, so a minus 1 is by h of 1. And this should be equal, so 2 should be equals to a minus 1, so a should be equals to 3. Yes, a has a value of 3. I don't know what was so tough about it, but okay. Okay, so I hope you understood the solution. And now let's move on to the next question. Okay, so the next question is question number 8. So we have f of x is equals to 1 plus x for 0, x belonging to 0 to 2, close brackets, and then it is equal to 3 minus x for this. So determine the form of gx is equals to f of x, and hence find the point of discontinuity of g, if any. Okay, so let us see what does f of x looks like. F of x, right? So it would look like 1 plus fx for fx belonging to, let me use a razor, sorry, for fx belonging to this, and for less than equal to 3 greater than 2, we have 3 minus fx. Okay, so for our like understanding, let us draw the fx first. So it is 1 plus x till 2. So for 2, it would give me 3, right? And this would be closed here also and here also. And for x is equals to 2 on the lower half, we have 1. And at 3, it would give me 0. So this is what we have. We open or यहाँ पे closed. This is what we get, and this is equals to 3. This is equals to 1, 0, 2, 3. Okay. So when is my f of x is equals to 0 to 2? My f of x is equals to 0 to 2 for x belonging to this also, this also, this also, and this also. But it is not continuous, right? So I have to break it from 0 to 1 and 1 to 3, 1 to 2. So let's break it down. My f of x would be equals to 1 plus fx from 0 to less than 1, and then 1 से लेकर 2 तक, ठीक है, 0 से लेकर 1 तक, और इस वाले पे क्लोज जाएगा, इस वाले पे क्लोज रहेगा, उसके बाद 2 पे इस पे क्लोज है इसे, बट यहाँ पे ओपन रहेगा, फिर एफ ऑफ 2 पे ओपन, और यहाँ पे भी सब ऐसे ही रहेगा, एंड दिस इज 3 माइनस fx. अब इसको सॉल्व करने का तरीका कैसा होगा कि 0 से 1 के अंदर एफ ऑफ एक्स क्या है अपना 1 प्लस एक्स, तो ये कितना हो जाएगा 2 प्लस एक्स, और यहाँ पे क्या हो जाएगा एफ ऑफ एक्स की वैल्यू क्या हो जाएगी ओके सो आई एम रॉन्ग, अगर एफ ऑफ एक्स 0 to 1 के बीच में है तो मुझे यहाँ पे नेगेटिव वाला लेना पड़ेगा ना स्लोप, तो यहाँ पे मतलब मुझे लेना पड़ेगा 3 माइनस एक्स, यहाँ पे हो जाएगा 3 माइनस एक्स, सो हो जाएगा 4 माइनस एक्स, और यहाँ पे प्लस वाला लेंगे तो यहाँ पे हो जाएगा 1 प्लस एक्स, तो हो जाएगा 2 प्लस एक्स, और यहाँ भी प्लस वाला लेंगे सो 3 माइनस So it's like a 2 minus x. Okay. So this is what I'm getting. It's like a 4 minus x, 2 plus x, 2 minus x, 0 पे close x. पे open. ये हो जाएगा यहाँ पे 2 open x close पे 3. फिर ये अपन को 1 से 2 में चाहिए तो 1 से 2 कब देगा अपन को? 0 से 1. 0 से 1 एंड देन दोनों पे क्लोज्ड और ये देगा 1 से लेकर 2 तक. सो दिस इज व्हाट वी हैव. अब एक बार चेक कर लेते हैं. 0 पे तो कुछ नहीं होगा. 1 पे क्या आ रही है वैल्यू? इसकी 3 आ रही है और इसकी आ रही है 1. तो एक डिसकंटिन्यूटी पॉइंट मिल गया. अब 2 पे चेक करते हैं. 0 और 2 डिसकंटिन्यूटी पॉइंट्स है. 2 पॉइंट्स ऑफ डिसकंटिन्यूटी. यस. थोड़ा सा कॉम्प्लिकेटेड हो सकता है इसको सॉल्व करना, समझना. तो पहले क्या करना होता है इसमें, आप x को fx से रिप्लेस कर दो एंड देन सी द ग्राफ ऑफ fx कि fx किस किस तरह में किस किस x के लिए कैसे वेरी कर रहा है. अगर मैं फर्स्ट वाला fx में देखता तो मुझे दिख रहा था कि 0 से लेकर 2 के अंदर fx इज नॉट कंटिन्यूस. तो आई जस्ट distributed them into two parts of 0 to 1 and 1 to 2 because they were not continuous between these 2 points. तो 1 हमारे आंसर का भी पॉइंट ऑफ डिसकंटिन्यूटी हो सकता था. तो आई डिस्ट्रीब्यूटेड देम. नाउ आई चेक्ड कि f of x 0 to 1 में कब वेरी कर रहा है? जब x हमारा 2 to 3 में है. फिर हमारा f of x 1 to 2 में कब वेरी कर रहा है? जब हमारा x इसमें 0 to 1 में है, ना कि 0 to 2 में. 0 to 1 में 2 पे हमारे f of x की वैल्यू 3 पहुंच जाएगी. तो वो हमें नहीं करना है. थोड़ी चीजों का ध्यान रखना है. And always graph can always help you guys. जितना तुम draw करो, like the more you visualize and the more you draw your graphs and your diagrams, it would be more easier for you to solve. Next देखते हैं. Determine the value of a, b and c for which the function sine of a plus 1 x plus sine of x divided by x, okay, is continuous at x. So first things first, we have uh, sin x. तो अगर हम लिखें तो ये जाएगा, let me just write the L Hospital rule. First would be cos of a plus 1 times x, a plus 1 plus cos x is, should be equals to c, should be equal to half times x plus bx squares root of half, and then let me just take out the root first. I'll just solve the RHS side of the limit differently. So let's take out the root first and just solve the root. So 1 plus bx to the power half. Then I have this, and then I have this. So this gets cancelled. So I'm left with x here. So this gives me this bx, right? And now if I take x is equal to 0, this goes to infinity, and this should not go to infinity because I know that it is equal to c and it is a constant. So this should give me a in 0 by 0 format. So to get a 0 by 0 format, this should go to 0. No, this should not go to 0. What is the question, guys? Okay, so how do I solve this? I'll just differentiate once again and not just use much of my brains. So this and this gets cancelled. And for x is equal to 0, I'm left with half. So c becomes half. C value is half. And that is equals to a plus 1 minus 1 should be equals to c, and that is equals to half. So a is also half. So c and a is equals to half. A, so it's a plus 2 or a plus 1? What is it? It is a plus 1. So where am I getting this 2 from? I got my c value as half. So there is a plus sign, not a negative sign. It's a plus sign, guys. So it should be 2. Okay, my bad. A plus 2 should give me a half. So that is minus 3 by 2. Okay, cool. So this is the last ninth question also we're done with. Very easy question. Just had to put the RHS and LHS equals and get the values of different constant and variables that were given in the question. Let us see the next part. Find the locus of a and b for which the function f of x is continuous at x is equals to 1, but discontinuous at x is equals to 2. So let us see x minus 1 times b at x is equals to a minus b equal to 3 times of x at x is equals to 1. Positive. So a minus b should be equals to 3. One condition I have, and the another is 6 is not equals to 4b minus 1. So this gives me a is equals to b plus 3 and 6 should not be equals to 4b minus b minus 3 and 6 should not be equal to 3b minus 3. That is 2 should not be equals to b minus 1. So b should not be equals to 3. One condition I have. So if this is the case, then a should not be equals to 6. So they could be anything, right? Apart from this point, that is 6 comma 3, there could be anything. Yes, so the locus becomes this with the condition that they cannot be equal to 6 comma 3. That's it. So solving for the next part. This was a weird question for me, guys, also. Like, it's not a familiar question for me as well. So we did this one, right? Yes, we did. We did this one also. Yes, now we are on the 11th part. We did the 10. I'll just take it through. So we don't have any confusion. So 10th is done. And we are on the 11th part. So what does it say? That for f, a function belonging to real from 0 to like close 0 to infinity, so it is non-negative domain, be such that limit of f of x at x going to 5 exists and limit x tends to 5 f of x whole square minus 9 under root of modulus of x minus 5 is equals to 0. Then I have to find the limit. So how do we go about it? The first thing we should do is f of 5 plus whole square minus 9, and this is h. So what are the, yeah, so let's see what the question says. Just give me a minute, I'll be sorry. So I was saying, so read through the solution and I'll give you a minute or two to read the solution and just get the solution by yourself for once, right? So get the solution, I'll be back in a minute. So I hope you guys must be reading. I'll give you half a minute more to read it. Just read it through, and I'll be back. So okay. So what does the question say? We have already read the question, right? So we can see that the limit is, for limit to exist, first of all, the denominator and numerator must go to zero. So the first thing that comes up to our mind is that if we take the put x is equals to 5 in the numerator, I should also get a zero there. So my first x would be that this whole square minus 9 at to go to 0. So by that I mean f of 5 whole square minus 9 should be equal to 0. So f of 5 should be equal to 3 plus minus 3. And we know that so it was range. Sorry, it was my bad. So okay, so my bad, guys. It had if it had been written a D, so it had been a domain side. But since it was written in R, so it was the range. So since the range of f is positive, so we'll just omit the another solution of minus 3 and take it as plus 3. Let's move to the next part. Okay, so now we are aiming at for our tough questions. So let us see. The first is we have to evaluate cube root of 8 plus x minus cube root of 8 plus x square minus x cube, this. So again, we know it is a 0 by 0 form, very easy to understand. So what is one trying to do here is they're trying to use the L'Hopital rule directly. So we can also do that. The solution, you can see the solution. This is a 0 by 0 form, as you can see very easily. So we have just simply differentiated and calculated to get the value. Very easy to do so. Just okay. So yes, as I was saying, you can simply differentiate and get the value. So very easy. So I'm not solving that. Right. So let's solve this question. This question also seems like we have to find the limit where this is going to infinity. So if we multiply and divide by this, so what are we left with? This. Again, we do the same, or if we rather do not do the same and just divide it by root x, we are left with this. And we got our values, right? So the solution, guys, see, that is the problem with maths and solutions. If you already have solutions now, then you lose your interest of solving a bit. Not necessarily for everybody, but especially for me. If I have a solution in front of me, then I lose my interest to solve this question because I know the solving process of a question gives me a endurance up. So it was very from person to person, but just giving my opinion. Okay, so I'm not seeing the solution in this case. Let's do the third part by ourselves. So what do we have? One summation of I is equal to 1 from n r plus 2 times of summation 1 to n minus 1 r cancel that n times of 1 divided by n to the power 4. So it's very series and sequence based question. So let us solve. We have 1 times of n plus 1 by 2 plus 2 times of n minus 1 n minus 2 3 times of n minus 2 n minus 1 by 2. Right. And if we try solving this, what am I getting is if we take the R and 1 also inside, so it's basically a summation which looks like just give me a minute. So it is n plus 1 minus I n plus 2 minus I by 2. Where our I is starting from 1. And it is going to basically, no. So yeah, I went wrong somewhere. Just give me a minute. So we have I. Okay, I was right. I n plus 1 minus I n plus 2 minus I by 2, and summation I goes from 1. There should be an n, right? Not 3 here. Why do we wrong here? What is the question here? Yeah, it is an n here. Why did I write a 3? It was causing me a lot of. So it is an n carry. So it is going to 11. Right? Okay. So this is what we have. And if we solve this, let us see what do we get. So let's take out half out first, and I'm left with this at n tends to infinity, and there is a n to the power 4 also here. So we'll take that into beta consideration. So first let us multiply and get our answer. So I times of n square plus 2n minus in, and then I have plus n plus 2 minus I, then I have minus in minus 2I plus I square. Let me erase this. Okay. So what am I left with? Let's collect all the terms without the I first. So we have n square plus 2n plus n plus 2. Let me just cancel them also to avoid any confusion. Then I have minus in minus I minus in minus 2I, and then I have n square. So let us see again. So half times of n square plus 3n plus 2 plus n plus 1 by 2. There was summation, right? And then I have I square. There's a negative sign. Let's take the negative form. I square summation of inverse summation I square. I've taken the negative form, so n to n plus 3, right? And then I have plus only, is it a plus? It is a plus. So plus times of IQ. Okay. So do we know the summation of I? There is a formula, right? So let me just search it through for you guys. I didn't remember them in my JEE guys, but I really don't remember them now. So let me just get the formulas. Summation. So okay, this is the formula for the summations of these numbers. So I have, I'll write it for you guys. N square plus 3n plus 2 n. This I have. Then minus half times of 1 by 6 n plus 1 2n plus 1 and 2n plus 3 plus half times of summation of IQ. And that is very simple. n plus 1 by 2 and the whole square. Simple. And now this whole term is being divided by 10 to the power 4. So let us solve this. See, we have a n to the power 4 terms everywhere, so let us divide and see what the answer we get. So it is 4 1 plus 3 by n plus 2 by n square, and this is 1 plus 1 by n. Okay, then I have minus of half or 12, and I'm left with this 1 plus 1 by n e plus 1 by n and 2 plus 3 by n. And in this case, I'm left with half into 4 into 1 whole square. So just putting an infinity here, this goes to 0, 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 this goes to 0 already. So that's 1 by 4, 1. Okay. Then minus 1 by 12 of 1 into 2 into 2, then plus 1 by 8. So 4, 3, 1 by 4 minus 1 by 3 plus 1 by 8. So this gives me minus 1 by 12 plus 1 by 8. And this gives me minus 8 plus 1 by 2. And 12 into 8 is 96. It gives me 4 by 96. That is 24. 1 by 24. So it went to be become very lengthy question, right? So it is, I hope it's right. I put quite some time here. It is 1 by 24. So a calculator question, but an easy question. I would say it was a tough question. You just had to remember your formulas, that what does the summation of m cube or m squared look like, and then had to just simply solve. So we got our value out. Now let me erase it. So my handwriting size went like bizarre from this small to this big, but that is the thing with screens, right? You don't know the ratio or like what is the is of it. So sorry for that. But I don't think that any that causes any trouble, does it? It does not. So let me just erase the other part as well. Yes. So we are on the third question as this. X to the power 4 sine of 1 by x plus x square upon 1 plus x cube. And again, x tends to minus infinity. So why is the minus sign important here? Because there is a modulus involved, and the modulus is the power of q. So it could cause a lot of trouble for you guys. So first thing that I also had in my mind, the solution also gives us the same example, that let x be minus y. So I'm left with y to the power 4 minus sine of 1 by y plus y squared upon 1 plus y cube. Very simple, right? I know my value, and my now limit y tends to infinity. So what I have to do is take y square common. But that does not work, right? I just no, that does no. We should not do this. We have an infinity by infinity case. So what one thing we can do is, okay, so yeah, I was going right, guys, or I was not. I'm still not getting this. Wait a minute. So okay, they have just different things out. So at y by infinity just gives me 1. This gives me 0 rather, sorry. So this gives me 0. And yeah, taking the 1 minus y, okay, and just bend the solution and just see, guys. So this is what the important bit is. This limit would go to 0, y would go to 0. You know the answer, right? So this would go to 0 and this would go to minus 1. So we have our answer. Can we take one more question? I hope we can take one more question. So let's do one more question. We have, without using expansion or L hospital tool, That was a boring question. I'm not doing this. Okay, we can do this one. Find ABC such that AX is for x minus b over 1 plus x minus plus cx minus x is equal to this. Again, I just read through the solution for you guys. What are we doing here is we are taking L'Hopital rule. We tried to put the value of x equal to 0 and we were getting a 0 by 0 case. So it's very direct indication that we can use the L'Hopital rule. We applied the L'Hopital rule, we got the values. So it was not applicable right now, but this condition can be used, that is a plus c should be equal to b. We have one condition right now. So now again applying the L'Hopital rule, we have this case, and again we got a condition. So we got two conditions. We have three. But we have two conditions. So we'll have to differentiate and apply the L'Hopital rule once again, and we apply the L'Hopital rule once again and get the third equation now. So by getting the third equation, we have three equations, three variables. We can easily solve them. This is the calculator bit. I think you can solve it by yourself. I'm not doing the calculation for you guys. So I think let's end the session by this. I'm already done with my questions. I'll try to put up the PDF link in the comments of the video, but if not, you can like search through the previous year questions. You can easily find them online as well. So okay, I'll end the session for the time being. Thank you for joining in, and hope to see you soon in my future classes. So okay, bye.